second part of lesson number 2 that is covered in exercise 2. Let's go over the answers for these exercise. The first question is, a hub is a dash duplex device. It's a half duplex device. So the correct answer is A. Question 2. If two PCs connected to hub transmit at the same time, dash occurs and the data is dash. So when two PCs that are connected to the hub, if they transmit at the same time, or what we call as simultaneously transmit, data, the collision will occur and data will get corrupted, and when the corruption happens, data will get lost. Okay, so the option for question number 2 that is correct is A. And then the next question, question 3, asks about at which layer does the hub operate. So hub operates at the physical layer or layer 1 of the OSI model. So the correct options are B and D. Okay, in the question 4, there is a topology shown, and again the same question as asked in question number 2 is presented in a visual way. So in this case, PC1 and PC3 both are transmitting, and now the question is what can be interpreted after looking at the following diagram. Okay, PC1, so the correct option here is PC1 and PC3 both are trying to send a frame, a collision will take place and data will get corrupted and lost. Okay, moving on to question number 5, what does the acronym LAN stand for? LAN stands for local area network. Okay, similarly down the line when we go into WANs, so the acronym WAN stands for wide area network. LAN for local area network, WAN for wide area network. Okay, moving on to question number 6. In the following diagram, how many LANs are present? Okay, so if you can see, there are two hubs here, right? In both of the hubs, there are 3 PCs connected. On hub number 1, PC 1, 2 and 3, and in hub number 2, there is PC 4, 5 and 6. But these both hubs are not connected to each other. That means they are separate networks, or you can say separate LANs. Okay, so the answer for this question is C. There are 2 LANs in this diagram or topology. Okay, now extending from the question 6, we same topology, but the question is which of the following is true. Now when these are 2 separate LANs and there is no connection, no wire connecting the 2 hubs, obviously they are going to be isolated amongst themselves. So PC1, PC2 and PC3 can communicate with each other. PC4, PC5 and PC6 can communicate with each other. But PC1, PC2, PC3 will not be able to communicate with PC4, PC5 and PC6. Plain and simple. So the correct answer is, since all of them are correct, A, B and C options are correct, the option D can be safely ticked as the best answer. So all of the above. Now moving to the next step, what we have done is connected the 2 hubs together using a wire. Okay. Now, and then the question has been framed that how many LANs are there. Now since they both have been connected, it becomes a single LAN, and that's why the question answer to the question is how many LANs? 1 LAN. Okay, and then here the question is what about the communication between these? Can they communicate with each other or not? In the following diagram, which of the following is true? PC1, PC2, PC3 can communicate with each other. That was always the case. PC4, PC5, PC6 can communicate with each other. Yes, indeed. And now, because the wire has been put in between, the possibility of them communicating with each other has become true. So, option C is also correct. PC1, PC2, PC3 can communicate with PC4, PC5 and PC6. And that is why we say all of the above. Okay. Moving on to the next question. In the following diagram, again, PC1 sends out a frame. Which of the following are true? PC2 and PC3 will receive it. PC4 and PC5 and PC6 will not receive it. Again, just trying to pass on the same concept in different ways, right? Framing the question in a different way, that is the intent. Okay, so simple, option A and C are correct here because there is no wire connecting the two hubs. Okay, so that's why whatever PC1 is sending, PC4, PC5 and PC6 will not receive it. Okay, moving on to the next question. Now we have put a wire between the two hubs and the question has been reframed, asked. PC1 is sending out a frame. Who all will receive it? Okay. Keep in mind there is a difference between receiving and accepting. I'm not asking the question whether they will accept it. It's a different thing that they will receive and then check the destination address, and if it matches, then they will say yes, it is for me. If it does not match, they will say drop it. But there is a difference between receiving and accepting, receiving and dropping. Okay. Alright, so in this case, PC2, PC3, PC4, PC5 and PC6 will receive it. That means all the remaining 5 PCs will receive it. And now the question is, in the following diagram, PC1 sends out a frame as shown in diagram. Which of the following is the true? Just a minute ago I explained the difference between receiving and accepting versus receiving and discarding. Okay. So now here is the DA value has been set to D. So PC1 sends it out. Now who is it intended for? It is intended for PC4, which is having the MAC address D. So now the option A says PC2 and PC3 will receive it and discard. Correct? Because the frame will reach PC2 and PC3. They both will check the destination address. Since it will not match with PC2's MAC address B, it will discard it. PC3 likewise will check the received DA, which is D, with its own MAC address C. It will not match, it will also discard it. Similarly, option C is also correct. PC3 and PC5 will receive it and discard it with using the same logic. PC4 will receive it and accept it. The reason PC4 will accept it is because the destination address in the incoming frame matches with its own MAC address. So again, the answer D is correct here. Okay, moving on to the question number 13. In the following diagram, if PC1 sends out a broadcast frame, who all will receive? Again, if you see, the same concept is being grinded down and passed in different ways, so that in one way or the other, wherever there is doubt, it gets crystallized clear with you. If there is, so the concept needs to be solid here, right? So whether it is broadcast or unicast, hub does not make a difference. And now the concept of LAN is being added, right? How many are there? 2 LANs. So who will receive it and who will not receive it? That is the purpose of these questions. So in this case, the broadcast is being sent by PC1. Obviously, the two hubs are not connected. The hub is going to blindly flood it because it's a dumb and non-intelligent device. So PC2 and PC3 will receive it. Okay. Moving on, when we connect the two hubs in the question number 14, who all will receive it? Everyone will receive it, right? Because hubs just flood the frames. Okay. I think that's pretty much it. Now, if I had to add one more question to it here, saying that if PC1 is sending a broadcast frame as it is in question number 14, who all will receive it and who all will accept it? So the answer for that is all will receive it and all will accept it. Okay. With that, we can conclude the answers for discussion for answers for quiz number 2 or exercise number 2 for lesson number 2.